Now, dear students, let me ask you something. How on earth do we take a whole piece of land, a field, a road, an entire city, and fit it onto one small sheet of paper? Impossible, you might think, but surveyors do it every single day, and the secret is a beautiful little idea called scale. Come, let us discover it together. So, what exactly is a scale? Think of it this way: the ground is enormous, but our paper is tiny, so we shrink the ground down by a fixed ratio until it fits neatly on the sheet. And that ratio, dear students, is the scale. Now, here is something interesting. When the scale is large and we show a small area in fine detail, a plot or a building, or we call that drawing a plan. But when the scale is small, showing a huge area like a district or a whole country, we call it a map, plan, or map. Just the scale decides. Now, how do we actually write the scale? For that, we use something called the representative fraction RF for short. Listen carefully. The RF is simply the distance on our drawing divided by the real distance on the ground. But remember one golden rule: both must be in the same units. Let me show you. Suppose 1 centimeter on the paper stands for 10 meters on the ground. 10 meters is 1000 centimeters, so our RF becomes 1 by 1000. Simple, elegant R, and it works in any unit system. Now, there are three lovely ways to show a scale. First are as a simple statement, like 1 centimeter equals 10 meters. Second are as that representative fraction. And third, my favorite, are as a drawn graphical scale, a little bar sitting right on the map. And why is it my favorite? Because if the paper shrinks with age, the drawn scale shrinks along with it and stays perfectly correct. And these drawn scales come in types too. A plain scale shows 2 units, while a diagonal scale can show 3. Now let us classify our scales by their size. Picture this. A large scale are, say, 1 by 1000 or zooms right in on a small area, showing every little detail like the plan of a single building. But a small scale as 1 by 10,000 or even smaller as pulls far, far back to show an entire city on one single sheet. So remember this golden rule, students. The larger the AFA, the larger the scale, the smaller the area, and the greater the detail. Now, here is a real-world problem. Paper is delicate. With age and with humidity, it slowly shrinks. And a shrunk map reads short, giving us wrong distances. But do not worry, dear students, we fix it with the shrinkage factor. It is simply the shrunk length divided by the original length. From it, the shrunk RF equals the shrinkage factor times the original RF. And to find the true length, we just divide the measured length by that shrinkage factor. Clever, is it not? And what if someone measures a plan with the wrong scale? By mistake, no panic. The correct length is the RF of the wrong scale divided by the RF of the correct scale times the measured length. And for area, we simply square that ratio. Oh, and before we finish, keep these units on your fingertips. 1 hectare is 10,000 square meters or about 2.47 acres, and 1 mile is 1.609 kilometers. So dear students, let us lock it all in. A scale reduces the real ground onto paper. RF is the ratio of drawing to ground. A graphical scale survives paper shrinkage, and a larger RF means a larger scale. That is the whole concept of scale, so simple once you truly see it. Now, if you would like these notes, just tell me in the comment section below and I will happily share them with you. Do try the practice paper too, and if this lesson helped you, do subscribe to Learn Civil Easy, press that bell and join us on Telegram. Keep it simple, keep it consistent, and happy learning.